We can, before the class starts, we can go ahead and mark some of the points that as written for the training sample. Huh? Before the class starts, we can mark all the points and carry it forward on training the model. So here that I'm marking some of the water bodies using the NDWI. Let's see areas. Okay, I can see the it has been activated over there. There is some water bodies that has been specified by the NDWI index. We can mark it as a polygon in this area, waiting for the layer to be lowered. If you haven't marked the training sample point, you can mark with me. Before the class starts, I am marking the training sample points, because going to the next and last step of the Google Earth Engine training of the land use land classification, we need to have some training sample data. Since this is a training, I will mark only very few of the training samples, but if it's for the research purpose, it needs to be marked for more than 20. If it's polygon 20 training points, if it's like 200, 100 is needed in order to have an accurate model. In order to mark the cropland, I'm using NDVI again, but we can basically have the idea when it comes to cropland, the vegetation has been reduced. With the idea of the topography of the Colombo area, I know that specifically this area have croplands, so I can use easily rather than on the capital side. In the middle of the side, I can find the areas. What I'm doing right now is marking some training sample points. You can also follow, it's the same, the last step that we have been done, just marking as much as you can possibly of training sample models.
Okay. Okay, so you can see that just for this training session, I only mark very few. You can see one, like, you know, 2 or something, but I recommend you to go for more than like 50 or 100 points. If it's points, more than 100 to 200 points, polygons, exact like 20 30 polygons if you can, because more training sample data with the area that you have, the more accuracy the model will be, because this is supervised classification. In the supervised classification, if you provide less training sample data, the confusion matrix, the confusion within the model will be high. So the accuracy of the model will be low, which means you will not get a good outcome of the area and everything that you wanted of the land use land classification. Have everyone finished? Okay. Okay. Okay, I will tell you. Meanwhile, that you can do the same time the what we call training sample model. Yesterday, if someone who have not come, we have started from on top. We have started from creating different kind of land types, and it has been open as a variable of a land cover, and we have 5 land cover types, and we have merged these land cover types under the variable of land cover. Then after that, what we have done in here, printed the variable what are inside the each the training samples that you are giving. So every time whenever that you created the each land type, and you mark any point of a training sample data, that has been recorded in the top. If you go into the top and see each land cover type, how many polygons you have marked, how many points you have marked. So that what we will be checking in here by printing. Exactly, it will be come into our console. And the second, what we have been done is taking the bands, except the bands that usually comes with the Landsat 8 bands, that we have added 3 different bands. Make sure if you added any other indexes, snow index or BSI or any other indexes that we have, make sure you add them into these indexes as well. These bands, under the bands, the variable that we have been created, within the LULC model. And after that, we have renamed this land cover property variable into the class property. Then this class property has been variable has been opened as image. For that variable of image, we have called the composite image. You remember the variable composite image? We have been printed the composite, which means without the clouds. We have done the cloud masking, and there is a one image after taking whole set of images we have within the 1 year period. So that is what we call composite in here. Within this composite image, the single image of satellite image that we have, we select only the bands we need. What are the bands we need? We have mentioned in here. We only took these bands, and NDVI, NDBI, NDWI is exceptionally we took because we needed them on the training sample data. If you want more bands, you can just add in here, and it will be also called in here. That is means select bands. Then after that, we click to our region of interest. Then we have one image, that variable. This image variable will be using our sample training data set that we are giving, and then after that, using this class property, which means the land cover, these different types of properties has been used in here. We will be adding them randomly into the random columns. Like in here, we have mentioned split it to 0.8, which means in the model training, Dinesh last time told, when we are training a model, we need some of the training sample model as well as we need some testing samples, because to check our model is accurate or not. So from some of the data that you are giving already, we will be using just not only to train but also to check. If anybody in here knows about modeling, let's say, okay, let's say, have anybody in here used any models before? No one. You remember that when we are using any kind of model, we try to do the forecasting, not forecasting, like forward and backward. The model has to be sometimes run. Backward, we are running to check whether the model is coming with accurately onto the location that we are using. So forward one is for the training. So testing ones will be used for checking whether it has been accurately come or not. And in here we printed each of these how many samples that we have been choose. This print function will be print each function that we have been used, the training sample, how many training samples in here, and testing samples. So all the time we are using the print function is to check. So that is all that we have been done so far on yesterday. And today we will be do the LULC classification. I went so fast because we already did yesterday. Okay. So today we will be do LULC classification, which means that you remember last time Augustine told us different type of we have classification methods. So in here we will be using minimum distance, the classification method. If you have been already finished up to here, then we can start coding. After finish the code, then I will explain one by one for you. Okay. I will zoom so the back can be seen easily. So we are using the cart. Cart is used to run the model. Okay, I think the back can see. Okay. Then I'm opening a variable named classifier. Then we are using the EE classifier minimum distance. This function is already being used. So you can see other classification method as well. If you go into the doc and type each classification method, you can see this method has been already defined in the Google Earth engine. So if you think, if your region has a good minimum any classification method, then you can use that classification method. Same time, you can also do a research about this one, whether what classification method gives the most accurate model for your region on the land use land classification. So it's like two subsection of your research. Maybe you can go as which classification model will be useful for you. So I'm going for the EE. Classifier dot minimum distance dot train. Okay. Features training dot select then we have to type all the bands that we have been used. SR underscore B3, the same bands that we have been used on the top for training. Okay, you can copy and paste as well. Since this is another within the variable that I'm calling this one. B4. And the other indexes that we have been added as layers to be added, NDVI and NDBI and NDWI. NDWI. Okay, so those are the all bands that we do have, and after that we need to okay, so we go for the no, not in here. Then after that, class property. Yes. Did I put NDD? Oh, okay. Sorry, NDWI should be. Class property. Class property is the class property. You remember the variable that we created on top? We called into here. We comment in here. Pull the land cover properties from the from classes. Input properties. Input properties are bands. Bands. And we finish this one. Over here, we need to put a dot and a comma. So within the variable of classifier, we finished. Oh, in here we need to add the land cover as well. Remember the land covers? We created the what we call water. These things, training sample data also need to be added in here. So we are adding this one, land cover. Okay. So I will write in here. No, if I write in here, you cannot see. No, I will write in the down. Write in here so you can see easily. I'm writing this one in here. You can write anywhere on the comments. Okay. Okay. So okay. So what we have been done in here, up from here we started a variable classifier. We open a variable named classifier. Then we use the EE classifier minimum distance function. There are different functions that you can use. You can write classifier, EE classifier. If you write EE classifier in the docs, you can see different type of classifiers that we can use the functions on this code on this section. Okay. If you type this EE classifier minimum distance, then you can see all the properties that including features, classifier properties, input properties. These things, the sub things that we need to put under this already defined function. So within the function of EE classifier minimum distance dot train, this function needed features. What are the features? The training samples that we have already given. See on the top you can see the training, testing and training. Okay, this one I select the bands of our visual bands and the indexes and the land cover properties. And after that, the class property is class property function. You can see the class property variable that we have been created on top. This is the training. These are the data and class property. Class property is land cover. Okay. So we have called this one into here, and input properties are bands. Okay. The bands variable that you have been created on top. The bands variable. Okay. So the model is done. So we can just run, but you cannot see anything because we haven't added to the map. But before that, we will also do one thing, because we already have testing sample. We only use the training. We only train. Now we need to use the testing. We have, I told you, like 0.8, which means a part has been used for testing. We have keep some of the you have selected some of the areas on your model. You remember this one? We will be divided into testing and training. Part that has been using as training will be used in this function, and the other part will be used into testing, which means how much accurate that you have been come up on your model. Okay, so now we are going for the part of testing. If you have done, then we can go for the, I'll keep this one in here. So those who have not done, they can also finish. Now what we are doing is testing the accuracy of the model. We are creating a variable validation equal testing dot classify should be CL
ASS. Classifier. This one, the variable that you created for the function of minimum distance. Classifier. You can just double click. You can see this one comes up here. That variable. And now variable is test accuracy. Validation dot error matrix. Oh. And now we can print it. Nope. Printing means printing on the console. When you use this function, it's print on our console. Validation. Oh. Copy from. Okay. Classification. Okay. Okay, no, correct. Classification. Okay. And validation. Error matrix. RF. Okay. This is just coming in the printing version. Okay. So it will be just print. And what we need to be print? We need to print this test accuracy. This variable within the function. This. And dot and comma. And we need to again print. Oh, this. Okay. Again print. Validation overall. Overall accuracy. RF. Okay. Now what we need to print in here? Test accuracy. This variable and the accuracy. Dot. Okay. This accuracy is one of the defined functions that you can use directly. Okay.
Okay. I already talked about this one. So in here, what we will be doing is testing our accuracy. The testing sample of data now we are using that we have been divided into checking the accuracy of the model. Okay. So in here, this classify, we are using two methods, validation and testing accuracy variables, and it will become as an error matrix. You can see in the error matrix how much confusion when you use this error matrix. You know the matrix, I think. So in the matrix, this will give how much confusion within each land cover type that the model has been taken. So it will become as one of the matrix, and it will become from our starting from I think we start from build up. So the build up over here, and after that let me check. I forgot the order that we have been put inside. Okay, you can tell me, no, so others can type. Go to the count. Tell me the forest. Another one, cropland, Barrenland, and water. Okay. So it comes as the matrix will be on build up again in here, and forest, and cropland, and Barrenland, and water. So you can see in once we printed, you will see there will be numbers that comes like in here, 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 here. Okay, like this, which means how much confusion that the training sample data that will be going on within the matrix can be comes within this for us to build up. How much it will come in here. So cropland to forest, if there's any confusion, there will be number. If there's no confusion, it will come as 0. But mostly you can see this build up and barren land will get some confusion. Forest and cropland will get some confusion if you don't have enough training sample data. Water and build up, no confusion will come because these are like two different indexes they will be using. And the barren land and water also no confusion. Mostly water bodies will become as cities without any problem. But if there's something like wetlands, then there will be some problems. Like, you know, some I think some regions have wetland agricultural fields. So that will be sometimes will become as confusion. So up so far we have already done our classifier and classifier, which means our minimum distance running the model, but we haven't added this one into our data set, which means one of the crucial part for displaying in our map. So what we have to do next is adding whatever the class this variable that we have done within this function into the data set that we already have. So what is the data set we already have? We took it as image to inside. So we need to put this one variable into the, let's create this one. So after this one, now we are going for the displaying in our map. So you can see that the display will become into the map. Okay. And we are typing this one, classify. Let me go. Now opening a variable name classified. Okay, DRF. Any name you can give, there's no problem. Then what is the image? Select the bands, and in here what we are doing is select the predictors, and after that what we need to do is dot classify, no, classify this one. This one. Mga seated enjoy karke hithi. What we are doing in here is classify applies the random, no, not random. What is the classifier we are running? Is minimum distance. Okay. Okay. Now we have added into our data set. That is what we have been done. So we have an image now to display. So in order to display the image, can anybody in here tell me what is the best suitable color ramp or something? Do we have a color ramp for this one? No. I think it's best that the colors that we have already choose. Okay, let me wait for you guys to finish this one. We can use the color exact color ramp number, and we can call it, which means for a red we have a number. You can check the number by going into the down data set, and you can find the number of the exact color. Then you can add these numbers into the color palette. Oh, ah, ini magi kat gahwal na. Okay, now I'm showing you how to find the color ramp that we needed. We have already choose some of the colors that we needed to use. So how do we choose this one? Let me show you guys. Once you go over there, build up. If it's like something that is built up in your land use land classification image, you can show from red color. What is the code for the red color? You can go into the settings, and you can find the numbers in here. Yes. Color X code, no? Hex code. Visualization. No, over there. Ah, yes. We can check that like that. Yeah, this one is for green. See the red is coming like this. These color ramps. Okay, like that you can find all the color ramps. How you been creating a color ramp? You need to create a color ramp as a variable. Okay, I'm creating a variable, so you can also follow me. Variable color ramp as LULC. No, we will not use LULC. It will become as yeah, color ramp. Color ramp one. Okay, I'm using it like that. Any name you can use for the variable, there's no problem. Okay, don't use something like confusing like already used variable name. And within the box you can put the color codes. The color codes you can find as I show you guys. Okay, or else from here as well, both fine. Oh, okay, I will expand it. Okay, MVC can no. I'm just typing the color ramp numbers. Okay, 061 AFF. We remember the red color is FF 000 not 000, 4 zeros, no? Yeah, 4 zeros. But again, you remember that green color have different green colors. Okay, light green have a different one, blue have different blues, navy blue and dark blue or something, a lot of colors. Zero. Three AFF02. Okay, this is one of the color ramp. You can check all of these colors on the Google as well. You can find each code. Same time, you can just type the color name and you can find the code. You don't need to write the hash. Okay, this one. Where can I find hash on my? Okay, this one you don't need. And with this one, we are adding this one to the map so you can see the final result. Final result or error message if there's error or spelling mistake. Then we can find the where the error is coming from. That's the most interesting part, I think, until you finish everything, you cannot find the error. Should be layer. Add layer. This is a, you remember this function, no? Anything for adding into the display. So what we need to display is this one, classifier DRF image. And after that, we have to give the minimum and maximum values of the color. This is for the colors. And what is the palette? Color palette is, we use the cramp one. Okay, and the layer name, after that we need to give layer name. This layer is LULC. Okay, then we can finish it. Okay, now you have already this part. Now once you run this one, you can find if everything is going okay or not. I already ordered the Dini. No, Dini, yeah, no, Dini checking for cook something. He came to cook for me. Okay, let me run this one. The layer got into a problem. Let's see what's the problem came up. Confusion matrix property land cover is missing. This property has to be added into the yeah, confusion matrix. Confusion matrix. Land cover. The error is coming from here. Okay, property land cover has to be added. Once the task has come, okay, task is over. This property land cover has to be added into the data set.
ඒකනේ වෙලා තියෙන්නේ. ඔව් මෙතන මේ C capital R capital වෙලා තියෙන්නේ. capital simple වල ගිහින් තියෙන්නේ. නෑ capital simple වල නෙමෙයි. cover cover cover. හා? ඔව්. උඩ දාලා තියෙන plan පොඩ මේ collection එක තමයි බලන්න. ඔය run කරා ඒතකොට තමයි අර error එකේ. මේ මෙතන නෙමෙයි error එක එන්න ඕනේ මෙතන. property එකයි missing වෙලා තියෙන්නේ. Yeah, if you got the error message, then you need to some land cover properties are missing. That's why land cover 2. Okay. Yes. If you got the error as mine, then what happened was, like, we yesterday created some of the property feature classes. On there we go for the feature classes and add the property, and you will see the property is missing. When you are saving, it will become as an error. So that was the error it came, because it was not marked under one feature class collection of property collection of land cover. Sorry. If you got the error, as you saw the error that I got here. Okay, so if you got the error in here, which means under the geometry property types, we have build up, forest, and these all the classes. So these all classes, what we call feature collection. So feature collection land cover type name we put is land cover. If you go into the settings, you can see under the feature collection, the property is land cover, and the value is 0, 1, 2, 3, 4. So which means a collection of things. And this collection, what happened yesterday when I'm saving my code, this was not saved properly. Yes. So what I have been done again is I again re-added. I again added the same things into here. So the code has been identified as a feature collection. So it can easily run this LULC classification. So you can see that the LULC classification has been done, and now it's 7:42. We can take a small break, and while you guys have maybe 10 minutes break, then what will be after the training, after the break we will be doing, calculating the land area that we have been come up,
And next we can do is downloading this one LULC, and the same time we can do accuracy checking that I already told you about the kappa and total accuracy. So producer's accuracy, this thing we can calculate, then we can end the training. Okay, just take a 10 minutes break. Thank you. You want the code? Machine classifier. Okay.
In the geometry import properties, you have to go every class. How many classes you have?
5. Yeah, 0, 1, 2, 3. 2, 3, 4. Property type is land cover.
Now, every time you have specify about land covers, you land
ඒක උඩ ක්ලික් කරලා ඒක බලන්න. නෑ මේ අත ගන්න අත අරගෙන ඒක උඩ ක්ලික් කරලා දිනන්නේ. Hmm? මොකක්ද එර එක දෙන්නේ විනාඩියක් දෙන්න ඊයේනේ oh my god sample image column random hmm? මෙතන රැන්ඩම් කඩපු තැන තමයි ප්‍රශ්නේ කියලා තියෙනවා. එතන ගහලා නැහැ ඒ ටික. සාම්පල් ඉමේජ් සාම්පල් රීජන් වලින් යව නවත්තලා. ඒ ටික ගහලම නැහැ එකක්වත්. ඔව් මම මෙතන ඉඳන් ගහන්න මෙතන තියන්න මයික්. ඔයක ඕපන් කළා විතරයි ඒක ඇතුලේ ප්‍රොපර්ටිස් ටික දියන්නේ නැහැ. කලෙක්ෂන් එක වෙන්න ඕන ලෑන්ඩ් කවර් මොකද? ඔව් එන්නේ නැත්තේ හේතුව ඔයා මැද කෝඩ් එකේ ගහලා නැති නිසා. මෙතන ඉඳන් ගහන්නකො. ඔය ටික ගහන්නකො. නිමාශය හරිද? Okay. දිනේෂ් මෙයාගේ අවුලක් යනවා. Okay. Okay. Now we already have, I think all of you got the LULC model, no? Everyone got the layer of LULC? Land use land classification layer. A layer like this. A layer like this. Nope. Any error comes? What's the error? Composite is not defined. You need to take the composite from here. It's your composite image. Huh? There's a composite image. You only have up to there? No. We have typed a lot. This is just... No. We were on like 200 something. You only have still on... Okay, I will send the code. So... Yeah, I will send some. Yeah, I shared it. Okay. What we will do in the next is... Check. Okay. What we have to do next is calculating the area. Okay, I will put the calculating the area. Okay. Oh, let me zoom it. Running a for loop. This is the method that if your area also big, a lot big, you can also run a for loop, I told you. Okay. Like, which means a loop that you will be downloading one area by one area by one area on the code. So this is a for loop that is also running for calculating the area. From 0 to A5 and asking to give plus plus. Okay. You know about the for loops, right? Tell me this for loops. Yes. Tell me what is this for loop will we do? No idea? Okay. This for loop is go from 0 to 5, which means we already have, we given feature class type, not 0 to 5, 0 to 4. Yeah, if it's 5, then it should be equal or, you know this one, equal or smaller. Mark has to become. So this one will be go up to 4. If you have more land cover property types, you need to change the number in here. Yeah, change the number in here, like any number you want. If it's 5, you have to put 6. So this will, yeah, more than 6, then it's 7. So it will go from calculating the area starting from 0, the land cover property type 0, it starts from there, then AA plus, which means it will be adding another one in order to create, calculate the following. Anything that we put in here, anything that we are putting in here within this loop, it will be calculating after one. That's what we call, like, you know, if your land area is so much big, you have a computational error, you can use this kind of like code for running the entire area that you wanted. So what we will write inside in here to calculate for one area, one land cover type, which means maybe like build up. We are only calculating the build up. Next, we are telling to the code to run it again to the next land type, which means 1, then 2, 3, 4. After the 4 only, it will be passing to the other codes that we have been already coded. So this is the for loop that you can also run for a bigger area if you wanted. I think Bishwa or something, no? Yeah, using the raster calculator. This one. This is the equation A that we have been told to go from 0 to 1. So every time we put another one, this A will be changed, okay? EE image pixel area. Capital symbol. Variable calculation equal x dot reduce region. Then within this reduce region function, we have to give the reducer EE dot reducer dot sum geometry ROI region of interest and CRS scale is 30. Okay. Now this is the function that we will be running for calculating the region. After the function, what we need to do is printing this information in our console. So for the printing, we are using print, but this also should within the our for loop. That's why this comma is ending from here, because you need to write one after one. So the print, oh, I will go for print ID, which means ID means that the class type number, it will be type, and plus a plus oh, okay. Dot divide. Okay. So we have the brackets open from here, and the brackets closing, brackets opening, brackets closing. Okay. Okay. This bracket is this bracket here. Then the brackets are okay, completed. So this will be running to calculate each land type and to be printing the area that we have. If you wanted, it's easy. Rather than doing from here, it is easy to do it from ArcGIS. You can download this one and use the ArcMap, the knowledge that you already have to calculate the area, also fine. So up so far, this one is like you can do it from here, or else you can do it from ArcMap. There's no problem. Sorry. Here? This one? Which one? This one? Up one. This one. This one. Calculation. Yeah. Yeah. Yes, it's better than we, because it's a variable name. Yes. Once you check this one, you can once you like highlight this one, you can see calculation. Okay, correct. Yeah, calling is correct. You see, no? Once you type the down one, you can see where it has been open. It's easy. All have been circled. Okay. So we have done the coding with the calculating the area, and next we have to done for our okay, I will tell a little bit of this one. I haven't told you guys. Okay, this is a for loop. This is run for every class, but we only type for one type. So which means it will go for run within the inside of this one. So for loop is starting from here, this comma, this bracket to this bracket. Okay, which means the print also should be inside the bracket. Okay, so entire thing will be go as variable x, the classifier drf, which means the classifier that we have already done on top. That is the, you remember that we have been already displayed on the LULC one. So the map layer that we have been displayed will be used, and it will be used for the equation A, EQEA, which means the land type, which means from 1 to 5, it will go 1 to 4, sorry, 0 to 4. Okay, each land type. So every time it will be adding this one A and plus 1, 2, 3, 4, 5, up to that it will go. And this multiply E image pixel area is already defined function. You can again check. So from here onwards, we are going for E image pixel area, and we are giving the pixel area, the variable calculation. This calculation variable is using for the x, this x variable x, which means classifier EQ, this variable has been called to here. And reduced region function, if you go into the doc, if you search, you will be see reduced region. This defined function, within the inside of reduced region, you need to give the reducer geometry, all this information. So that's why we have been given all of this information for this reduced region function. Yes.
You have to be careful about this one. So you have to be careful about this. Because it's different from place to place. If you are focusing on Sri Lanka, you can go with this one. But if you are focusing on any other country, you have to come. So you can check EPSG and this one. Just check what is coming up. You can like copy this one and
Yeah. From country to country, projection is different.
Sri Lanka is by UTM, another limit. And sometimes I know sometimes that country is different. So you have to check your UTM zone and replace this ESD course. Because we are going to the geometric calculation. For this one, you know, we have different coordinates. So if we focus on this specific area, we have to use this coordinate system. Then it will automatically calculate the exact estimate if you use this coordinate system for the other part or other, like coordinating in this 44 mode. What will happen? You will get the result, but the number representing is not accurate. It's different from place to place. So you have to check your own coordinate system and give this one, the value, only this one. EPST is like, say, this number will be different from place. For that thing, you can even use ChatGPT.
Okay.
So here you cannot make any changes to these things, okay? You cannot change, like you can change the rest of the part in here. You cannot change the release. It should be simple release. You cannot use like capital R, E, D, U, C, R. It's not going to work. Because you see, like this is a by default function. Reduce region is a function. If you go to the documents, you will see. Just go to the documents, you will see. Right? Then you will see what are the parameters you can use. Go to the documents and type reduce rate. So you can copy and paste it over. Then it will mention what are use less. So it should be in that order. See? We are using this one, reducer and then geometry. You click here, click here. Okay. For the arguments, you cannot change this argument. For reducers should be mentioned like reduce, not like capital R, A, D, U, C. Should be simple reduce. And this one geometry. You cannot even make any like mistakes for the data. Type GEOMATERY should be METER. So these things should be like exact. Otherwise, you will think like why we have to in CRS. We can put like capital CRS. Not going to work. It should be like exact thing.
Zoom in. Zoom in. Okay. Reduce region, reduce sum, reduces geometry are high. You're doing for Sri Lanka as well, no? Okay. Same scale is 110, 130.
This recognize. कौन दे रहेगा क्या आगे ना? Calculating array का क्या? X dot reduce ratio. Geometry में reduce के मैं spring से देना doc. 5 0 to 5, so 0 to 5, yes. 6 करा. That's mistake. ArcGIS CRD की नहीं लगती. Inside functions together. CRD. No.
That's the mistake. This one should be
Yes.
CRD.
CRD.
Coordinate. Yeah.
Yes. Sorry? Again, ask for this one. Yeah, we can check this one, like whether spellings are correct or not from here. Let me check. Geometry is correct. Scale, CRS, geometry circle, W scale. Oh, okay. This is not W scale. This is scale. Okay. Then now you can run. It should be run now. Oh, there shouldn't be. No. Wait. ID. Error that's giving. Divide is. Oh, okay. Spelling mistake. This would be DIVDE. Oh, from no, not divide. This is a dot. Sorry. Okay. Now it should be run. Okay, all are working. Oh, Dinesh, reduce this one. No, we have to put for 5 again. Yes. Dictionary error, user memory. Oh, okay. This is user memory exceedation limit means the area that we have been used is big. For calculation, sometimes this comes with the network error.
mostly. In the code, there's no error, but it says like user memory exceeds. For some, maybe it started to work. Yeah. If this error comes, which means the area is big, okay? But if the area is getting small, again, it will be work. Yes. ප්‍රශ්න තියෙන පම මේව ටිකත් අහුවෙන්න ඕන හැබැයිනේ. මම මාක් කර පොයින්ට්ස් තියෙන තැන් වල. Maybe you have done a different region, no? Oman. You done for the Oman, no? Some small region. Oh, you should. Oh, she's using different. No, different region.
But the same.
Oh, okay. You can small reduce maybe. Another bro. Oh. I shared the code. Yeah, I shared the code. Okay, you can check. Oh, okay. Still coming? No, still loading. Dictionary user limit expect. Not CRD, CRS. Okay, since we have very limited time, we will go directly to the accuracy correction because today's the last day. I need to finish. Next time, Tarafa will come. That's why. We have accuracy correction, different methods. Accuracy calculation. And what are the things that we told about the kappa? I think Bishwal told me about the kappa last time. We can use the kappa, and the same time we can use total overall accuracy and producer's accuracy. Yeah, those are things. So let's start to type. Those are already defined in here, so we just need to be typed. That's it. There's nothing else. So, and the same time, we can also go for the confusion matrix. This one needs the confusion matrix. Okay. Variable confusion matrix. Oh, I need to be zoomed. Matrix equal classifier. You remember the classifier that we have been used on the top? the classifier that data set we need to use. Classifier dot confusion matrix. Okay. Confusion matrix is a different, it is a defined function, so we just need to be print confusion matrix. Matrix, and we need to print this one. That's it. So this will be calculating directly the confusion matrix for the data set of classifier. So you can see the classifier data set on top that we have already to see classifier. This one, the LULC. Classifier is the LULC run variable. So we are using this variable, the LULC run variable, this one with the minimum distance, to be checked about the confusion matrix, and just that variable and confusion matrix will be automatically calculate the confusion matrix. We don't need to write anything. This confusion matrix is an already defined function in the doc. So again, we just do the printing this confusion matrix, this variable that has been calculated. That's it. And we can do it. And what are the other things? We have overall accuracy variable, overall accuracy equal. We need to calculate for this everything we are calculating for this confusion matrix, which is the LULC running function that has been inside on there, this variable. Okay, so confusion matrix dot what is accuracy. That's it. It's an already defined function. This will done the overall accuracy. Then what we need to do is print overall accuracy, this function. And now first write the name. What is the name we are using? Overall accuracy. And what is the function we need to print? Variable OA. Okay. Now we are done. And what are the other one? Is consumer's accuracy we can calculate. Variable consumer's accuracy equal to confusion matrix dot consumer I think he just come for the stamps, I assume. This guy just come for the stamps, I assume. He's just going over there. I saw the book is given to that guy and he's leaving slowly. Never bring anything. What is his country? Zimbabwe? What is his country? That guy? What is this guy's country? I forgot. Really? Huh? Oh, he's sick. I don't think so. He all the time go like that. Consumers accuracy. Consumer, yeah, it should be N. It's okay. It's just printing. Okay, it will come your name. Confusion. This one. This one. Oh, it's okay. This one we can, like, this is giving you just typing in the board. It's just like, printing. You can just write hello world. It will be print over there. no error will come, but this will be confused. Okay, I will be putting this one correct version. Confusion. Okay. And what we need to print is this one, the CA. The variable, the next one we need to calculate is what we call kappa, kappa coefficient. So we can calculate the kappa variable, kappa, and it can be calculated. Again, we are calculating for the confusion matrix, which is to our LULC, land use land classification variable. So I'm copying it, pasting our confusion matrix, this variable, and for the kappa, just kappa, and the kappa will be calculating for our area. So it's easy, simple. This area of calculating, you don't need to think anything. These are already defined function. You just need to be tied. And we can again print this one. Print. Printing is kappa. What we need to print also kappa. The variable name is also kappa. Okay. So it will be print the kappa. Okay. And after that we can print the order. Equal. We are calculating again for the confusion matrix. See, confusion matrix, and what we need to use is order. So now it will calculate the order. For not to get confused, I will put this one capital smart, and needed to be printed. This one, sorry, not equal. It's the same process where we are doing printing. Also, what we need to print, the name is order. Order and sorry, order. Okay. And what need to print is also this one, this variable, this one, and closing it up. So we print the order and producers accuracy variables, producers accuracy. We need to check for the what confusion matrix. Oh, okay. Oh, I took this one's confusion matrix. Dot. What we need to do is producers accuracy. So producers accuracy. Okay. Producers accuracy, and we need to a little bit up. Now what we need to do is print this one. Oh, capital P. I use the capital. Print. What we need to print is producers accuracy. I will take the name in here. Easy. Producers accuracy. This is P. Producers accuracy. Okay. And within this commas has to be put. Okay. And what is the variable that we need to put? Print is the PA. We are closing the bracket, and that's it. So we have done several testings. You can see we have done the confusion matrix has been printed, overall accuracy printed, consumers accuracy, kappa, order, and producers accuracy. So these are just testing, okay, about the model that you have been created, whether it is being okay or not. So you can use this data in order to, for your research when you are using any land use land classification, your own model. You need to provide this kind of accuracy testings. Otherwise, you cannot prove that your accuracy has been come up. If your accuracy on the kappa, if you reach more than like producers, let's go for like producers accuracy, it should be more than like 95%, 98%. You can see that I have one publication on this one. You can check on that one as well. I run these things. One publication on this one, okay. Other ones is different in aerosol side. Okay, next what we need to do is sorry. Error again. Okay, you can find this one. Yeah, these are just for checking the accuracy of the model. Error came. Okay, let me check. Oh, this is dot. You put a dot in here. Now it should be run. You better save this one, okay? This confusion matrix also didn't come. Yeah, it should be like, you know, this color, purple color. Dot confusion matrix. I think spelling is error. This one is the first one. Check the spellings that I used. Sorry, confusion. O-N matrix. Okay, now it will be run. See, purple color. It's just like, you know, classifier. This is the LULC data set, and we are running the confusion matrix. All the time we did this LULC one, consumer accuracy. This is the test. This is already defined function. So you don't need to like define it again. It will automatically calculate. Let's see any resources. Yeah, this is dot, not comma, dot. Okay. Accurate, you know. This is maybe like size is too much. The area that I give, yes, that comes. You can go down. This is for area calculation. Confusion matrices are done. See, overall accuracy is 90, 0. Yeah, this one is coming 0.99 means you need to again multiply it from 100. So it's 99%. It's 99% because the sample data set is small. Try to give more sample data set as well. Yes. X reduced region. This is CRD. No, CRS, not WS scale. It should be. Again, variable calculation. This calculation is calculation same. Let's check.
calculation. Okay, X reduce region reducer E is some scale is also geometry. Let me copy and paste this calculation. Okay. Control V. A plus 5. A plus oh, again, this one also come, but it's not the error. This one for delete. Let me put that part into my code. Check if there's a spelling there. Yeah, it says like because yeah, my one is correct. It's not the we need to find the error why it came. No. In here,
Right now it's okay.
no, it's okay. Oh yeah, this is spelling mistake. See, double E. Reduce. Okay. Okay. Now it should be correct. This big things is coming when the inside a small function. If there's any error comes up, that's why. In here also, yeah, kilometer should be like it should become like this. Okay, because kilometer is because it's just for printing. There's no variable called kilometer within us, but there's a variable called calculation. On top, what we did. Oh my god, so much sensitive. This is calculation. See, this calculation variable is over there, and there's again this is comma ke calculation. Calculation is okay. Yeah, you can copy from here. Yeah, we can. Oh, not if your control is in here. Control C. Control V. Values also done. Dot values. That 0 calculation. No, it is correct. It we have been already there. No, the error is comes from here. There's nothing error on the top part. Now there should be. Then the error comes from on the down. That part is okay. Okay, in here confusion matrix classifier. Yes, classifier should be then you need to copy from not here. The classifier we did on LULC classifier, this one. See, reduce minimum distance. This is the classifier. Control C. This classifier has to be put on every classifier. Everything is running for here for the classifier. You can check. Now it's correct. Yes. My name is Pasindu Liyanage. You can find me on ResearchGate or Google's. No, go to the ResearchGate. ResearchGate, this one. Yeah, because the user memory limited exceeds the area is big, which means like processing power. If you put like big area on the top beginning as well, it's also coming up again.
is you need to again reduce the region for calculating the area on here. You can run it as a whole for loop, or else you can calculate easily from using again by downloading this one from ArcGIS. You know ArcGIS formula for this one, not formula, you need to use the raster calculator. You can calculate the area easily. You know raster calculator. This one is because the area is big. It says user memory limit exceed. Code don't have a problem. Only problem is user memory limit, which means for free accounts they give like a limited memory. That memory has been went off. If you paid for the Google Earth, you can run for the entire country. You have to pay. Not this one, no. The first one. I will send you. I will send you. I will finish this one fast. The first one I did. Oh yes, I was slim at the time. And okay, now we have already calculated all the confusion matrix and everything. When you run the code, you will be see this one on here in our console. All the information that is coming up. So what left for us is right now is to download this all things. So you have already downloaded. Huh? To write a paper, now we already have everything. See, kappa, all the overall accuracy, consumer's accuracy, order and producer's accuracy, and everything is over there. Okay. So what we need to download is just need to be download this one. Anyone who can finish by themselves this downloading part? The last one, downloading one. I already told you guys about this one, downloading one. Have you downloaded the NDVI before? Did we? Okay, then we can finish the NDVI download and the indexes downloads. Yeah, we did the satellite image download. So see, this one I already teached you. See, so you can also like give a try. Let's give a try. I will come fast. So for you guys, you can see the publication on here. For anybody who wanted to find. Oh, not photos. I don't need photos. This one you can find the, go to the publication, you can find the paper that I have been published over here. I will show you guys. This one, Colombo district. So this one has been calculated. This one of the part of the paper is land use land classification. So this has been calculated about the how the green surfaces in the Colombo district area is helping to mitigate the urban surface urban heat ion. So from here also, from this land, from this one also, you can calculate several things. Not only the land use land classification, but the part that I have been promised is just to teach you guys about land use land classification. Okay. So same. Okay, then I will show you guys. Oh, okay, this is just for downloading this one. So let's go this one. You can see all this, see, kappa coefficient and order and everything came up. I will save this one. And this is the last part, okay? I know that your time has been limited. I will finish this one fast. You will not see me again. So I will finish this one fast. So in order to download the, let's go for the indexes. Since we haven't downloaded any indexes, I will show one index. Then you can continue this index to the same method for the other indexes as well. Okay. So downloading the final product, downloading the indexes. Let's say. Okay, NDVI. I'm writing for the download in the NDVI. Zoom a little bit. Okay, now everyone can see. So I am doing opening a variable NDVI, because this one, you remember the composite image, this has to be added into the composite image. Composite, okay, and select NDVI. We already added this one also, but again I'm typing since like within the code we have used the NDVI band several times. So it's better again I'm typing this one. So which means for this NDVI, this within the variable that I created as simple NDVI, this you remember the composite image, the final image, the image that you downloaded on top, this one composite, which means without the cloud, one single image. Within this cloud image, I am selecting this band called NDVI for this simple NDVI, okay? Because I only need to download the NDVI, not the entire other bands. NDVI is just one single band that I added into the final image, okay? So I have been selected this image. Now what you need to do is copy this one. You don't need to download the entire thing. Copy this one and paste. And what we need to download now, image, is NDVI. We have already selected in the here variable NDVI, okay? NDVI. And the description will be, you can put any description, okay? NDVI. This one doesn't matter, okay? Anything which comes with the single column in here for the description, you can give any description you want. Region is ROI, pixels also 13 again. But in here, we will be adding a max pixel values for here. Max pixel. Max pixels is my numbers. Comma, okay. Okay. So this is the same method that we are downloading all the indexes, okay. Either it is NDBI, NDWI. Oh. 1, 2, 3, 4, 5, 6, 7, 8. So this same method continue for the NDWI, NDBI, and everything. So now you know how to download the indexes, okay? Let me show you the final one as well. Can I? To download the LULC. It's 9 now, no? Okay. Give me 1 minute, okay? Just to download the LULC one, okay? We already finished just downloading the images that we have already done. That's the part left. And to download the LULC, now copy this one. It's the same method, okay? Now I'm downloading the LULC. LULC, paste this one, What is the LULC image? You remember? In here, if you go up, what is the one we added into the map? See, map, add layer, classifier, classify DRF. Okay, this is the variable that we have added into the map. So we need to download the same map. So we copy this one from here and paste on here, and this will be LULC image. Yeah, LULC, and the region is ROI and scale is 30. Okay, this one you can stop also downloading from GeoTIFF. GeoTIFF download also fine. Okay, when you download this code right now, not download, run the code right now, you can see what I have been added in here will become into the task. The task should become with the new one will be NDVI and LULC. Of course, the composite image should also come because it was on the top. Yeah, see, Landsat site composite image and the NDVI and LULC. You can download and put it to your Google Drive and use it on Google Map, or sorry, not Google, ArcMap or ArcGIS Pro. Okay, same method. So you can continue for this method for the other two as well, the other two indexes, not only the NDVI. So I'll just keep the NDVI and both in here. So you can continue, and we are done, and you can continue, finish it, and let me know if there's error comes for your code so I can help you out. Okay. Yes. Yes. Oh, why you put? How you come? Oh no. Okay, okay. Because you type, I think, run this one 2 times. That's why it comes 2 times. You can just run it and you can download it. Okay. Wait. Just single press. Okay. If you press double time, it will be again double. Yeah, you can put for the other indexes as well. NDBI and NDWI. Okay, now you can just go for this one. You already downloaded the other one. Just you can run it, and it will be going to your Google Drive. Then from Google Drive, you download as the normal that you download as a normal picture. If you want, you can download this one as well. It's me. I think we already done this one. Download this one. You can just give a one single name. Late we can give, because the task name cannot have a space. Yes. It came because of oh, there should be a comma in the bay in of the 5,000. This one. There's a comma over here. Comma. Okay. Here also after the max pixel comma. There should be. But you don't need max pixel in here. No need max pixel. It's for downloading the indexes. You can put it. Okay, you can finish the other indexes. And so, same time, I will also complete other indexes. Check the comma. You put the comma, no? In here, you don't need this one for the classifier D. Max pixels. From the above, okay. Okay, then there should be okay. Oh, the problem came is that you have to close this one. You haven't closed this one. You need to put this one in here. Brackets. Control C, we can paste it in here. Because you need to open, when you open it, you need to close it. So what I need to do is for other two indexes, is same download in the NDVI. Put the other two indexes in here. What is the other one? NDBI. NDBI. This one should be NDBI. NDBI. Okay, everything is done for the NDBI. Now what we need to do is NDWI. Go for the NDWI, and this is goes for the NDWI and NDWI, NDWI, NDWI. Okay. So NDWI. Okay. Now if you run, you can see other two indexes also I added into the here. So this one I will save. Okay, now you all know how to do this one. Just need to be run. Then it will be go into your clouds. Just need to run. And just run. It will go into your drive. Finish. Okay, then. Ek නිකන් open කරන්න බෑ download කරාම. ArcGIS එක open කරන්න. ඒක GeoTIFF එකක් නෑනේ. ඒක ArcGIS එක open කරගන්නකො නෝම. ඒකට ඇදලා දාන්න. ඒක open cancel. ඊට පස්සේ symbology වලට ගිහලා symbology වලට edit කරන්න. I also haven't ate. Finished. What happened? That is user memory exceed level because the problem is running the area size. It's too big. User memory is like every user have a limited space of exceeding. So when it exceeds, it is being like showing like this. But you can also again, when you download the LULC map, put it to the ArcGIS ArcMap. I think Emmanuel has already told this one. No? Now use this one. You can calculate because this is a raster image. So since this is raster, you can calculate the area size of each classes using the raster calculator. Yes. The order, printing order. Oh, this should be simple order. You put the simple order here. See, your variable is simple order. Then your variable should be capital order. This is the variable you are printing. We are putting the variable name. This is simple. This is capital in here. See, so you have to either put the capital or in here. Then it will be printing.
This is the last part, right?
Yes. If you want, I can do another part as well. Yes, if you download it, then that's just the part that I choose, but there are more that you can do for. Uh-huh. Yes, yes. Class is finished. Everyone who do have a problem with the codes, those who wanted to ask question, they can stay. Class is finished, and I will share the code for your references. I'm waiting until that your codes errors are finished, because when you type and if you get an error, that's how we learn. Using the same code again is not learning.